Good afternoon, we're Oliwia and Radman, engineers from TUE, and this is Aqua Verde, wind-powered UVC LED water purification for remote underserved communities. And in 3 minutes, we'd like to talk to you about the big problem, the big solution, what we built, and where we need your help. 3 numbers tell the whole story. 869 million people in sub-Saharan Africa lack safe drinking water. That's more than US and EU combined. That same region has enough wind to power itself 250 times over, but uses only 1% of it. And more than a half, about 600 million people, lack access to electricity grid. The wind is there, the need is there, the grid is not. Every existing solution now assumes that the grid is there. We, on the other hand, don't.
Here's how it works. So you have a wind energy source that produces a messy, unfiltered signal. Our power electronics clarify the signal and transmit it wirelessly over a sealed magnetic coupling to the UVC LED array. Now you might be asking, why did we go wireless? This is because the contacts will not contact with anything in the water. This reduces the risk of corrosion and any shock factor. And also, with the lack of contacts are most often the first thing that fails in the water purification systems. Now we have removed them, and as a result, it creates a much more reliable system. Our LEDs work at 275 nanometers, which means that it eradicates over 99.99% of the E. coli. As a result, we have 100 watts of purification with 0 chemicals and 0 reliance on the grid. Now I'd like to talk to you about our cost. Our cost was derived from a sized-up version of the bill of materials, standardized with the EPA drinking water standard. As a result, we determined that for our purification standards, we need 16 UVC LEDs to dose 1 tank. 1 purifier costs 225 euros, and a full unit, which includes the wind turbine, is around 625 euros. And this accounts for about 50 people's daily water intake.
And you might ask, why can't solar companies just add wind? They can build on a turbine, but their electronics are built for solar smooth power. Ours are built for wind's gusty power from the ground up. They also rely on big, high-density batteries and wire connections into the water. 2 things that fail first in the field. We use small LPF batteries just to stabilize, and a fully sealed wireless power transfer, a truly reliable solution in the field. So, in our honest opinion, the engineering, the hard part, has already been built and validated by 8 engineers from TUE with a clear roadmap to a field unit. What we don't know is the business. Who pays for it, whether we sell, lease, or deploy through grants, and how to take hardware from prototype to product. And that's our ask today. If you've commercialized hardware or work with NGOs or off-grid energy partners, we'd love to connect. Thank you very much.